lesson is the last main lesson of this unit. Okay, tomorrow's lesson we'll be looking at word problems, and Thursday will be the test. And we'll do a review before we're doing the test. Right, and so today's lesson should be quite quick. It's we've done dividing terms before. This time we're dividing polynomials. So dividing many terms by one term. Right? So the rules stay the same. Right? So if you have a number, we call those coefficients. What we do is we divide the coefficients. Right? And we simplify the fractions. Right? Then we also apply the exponent laws to the variables. So we're dividing. What were the exponent laws? So when we divide, what do we do with exponents? Subtract. So when we do the exponent laws, we subtract the exponents. Right? Because when we multiply, we add. So last time we looked at algebra tiles, and we said, hey, if we take the outside algebra tiles, they make up the shapes inside. Now we can do the reverse for dividing. And actually, I think it's probably the most helpful use of algebra tiles for dividing. So when you set up a division statement, so this is the kind of ones that they can look like here, is we have our numerator. That is the stuff that goes inside here. So that's our numerator. Right? We have 4x squares, and we have 6 negative x's. Right? That's our numerator. Now the stuff on the outside is our denominator. We have an x and we have an x. We have a 2x. Okay? Now, it doesn't matter if I put this here or on the top. The stuff on the outside is the denominator, and the missing side is what it equals. What our division statement equals. It equals. All right. Now, we use the same strategies as we did last time to find out what the missing side is. We go, hey, the length of the shape right below the side tells you how long the missing shape is going to be. This one is this long, so this shape is going to be this long. Right? On the outside, everything is only one high, so this shape has to look like this. Okay? Then next column over, this shape has to be this long, and up 1. Okay. How does the next 3 shapes look like? What do you think? Little squares. Right? This one's this. So this column is going to look like that, and up 1. This one's like that, and like that. Okay. Once you determine the shapes, you got to determine if they're positive or negative. What color are they? Are they black, positive, or they're white, negative? So remember the way this worked is the 2 outside shapes multiplied to make the inside shape. So here I have a positive times something has to be a positive. So what color does this shape need to be?
Positive.
Positive. Because the 2 outside shapes, maybe I'll color it in black here. The 2 outside shapes multiply to make the inside shape. All right? So what color does this shape need to be here? Yes, Harmon?
Are the colors always going to be black and white?
On tests and stuff, black and white. Some textbooks use like orange and yellow. It depends on the textbooks you're using, right? Or maybe red and blue. I've seen it too. Right? Depends on the textbook, right? On tests, they tend to make everything black and white because they don't print things in color. So this one has to be positive as well. All right. Next one. This one. What color does that one need to be? So positive times this is equal to this box, white. Negative. So it has to be negative, right? Positive stays white. And in fact, it's the same situation for this one. This times this equals this. So this has to be white, and that one has to be white. Right? So the missing side here is we have an x here and an x here. So you have a 2x, and you have a -1, -1, -1, minus 3. So if you were to divide this expression out, you would get 2x minus 3. That's what it equals. Okay? Okay. Let's figure out what our division statement here is. What did this represent here, the inside? Numerator or denominator? Numerator. So I'm going to set up my fraction. This is my numerator. So what do we have inside of our numerator? Well, we got to add these up. What does the big boxes stand for? Positive. What? Positive x squared, positive 1s, x squareds. And they're positive. And how many of these do we have? 6 of them. So this is 6x. What does those white rectangles stand for? Negatives. And -1, negative x squared, negative x, negative x. And how many of these do we have? 3. So our denominator, our numerator, 6x, oh, I forgot the square, minus 3x. So on my fraction line, I'm going to write that as my numerator. All right. Now, what does that means? This is our denominator. What is our algebra expression for our denominator? 3x. Right? This is an x. This is an x. We have 3 of them, so this is 3x. Okay. Last up, the missing side. So this one's this long. So this shape is this long. Right? It's only ever 1 deep. Okay? This one's this long. So this shape is this long. It's this deep. Finally, this one's this long. So this shape is this long. And it looks like that. The hard part now is determining the color of the shapes we drew. The first shape, what color should this be, black or white?
Black.
Black. Because a positive times a positive gives us a positive. So this should be black. All right. How about this one?
Black.
Black. Because a positive times a positive gives us this shape. All right. Last shape. Negative. We said negative times a positive gives us a negative. So that has to be white. So what is this missing side? Algebra expression there for that? 2x. Yeah. 2x minus 1. So this equals 2x minus 1. Okay. So now how do we do this without using algebra tiles? Right? Yeah, we just simply divide it. Now, what we do is we take this polynomial and we make it into a division of monomials. Right? We have 2 terms here in the numerator. We're going to split this fraction up into 2 fractions with a minus sign in between because that's the sign between those 2 shapes. 2 terms, sorry. Right? When our denominator doesn't change. We have a 9k and we have a 9k.
Why do you have to turn it to
All right.
You're just making it smaller. That's like-
Yeah. And now, the first term goes here. So we have 18k squared. And the second term comes the second fraction. Right? And now this becomes like what we did a couple of days ago, or a couple classes ago. We have one expression here that we can simplify, and another expression here we can simplify. Treat them individually.
Can't you do 1 over 2k squared for the first one, and then for the next one, can we do 1 over 1k?
1 over 2k squared is what Harinder
Or 2
said.
over
It's
1k?
2 over 1 and then 1 over 1.
2 over 1 is what Harinder is saying?
Yeah.
Because 80 divided by 9.
Yeah. So I agree with the number. 18 divided by 9, that's 2. Okay. What happened to the k?
Would it be K3?
That's what I said, k
Would
squared.
it be K3 or
No,
K2?
no,
it's
it's
minus.
minus.
It would be K.
All right.
Oh, yeah,
It'd be
because
K, K, K.
divisions.
Yeah. So when we are doing division, we subtract. Right. So 2 minus 1 is just 1. So k is going to have an exponent of 1. Now, we don't need the over 1 part, because anything divided by 1 is just that, whatever the number is. So 5 divided by 1 is 5, 100 divided by 1 is 1. So we don't
Can you put the k to the side of it, or does it have to be with the number?
It has to be.
it has to go with the number, right? Because it's part of the same term.
It makes it so messy.
Okay. Shh. Okay. We divide on the second fraction. We divide
You should do
the
1
9 with the 9. What do we get?
1.
over 1.
1 over 1. So we can just say a 1 there. What happens to the k?
It's
Disappears.
Disappears.
Oh.
K to the 0 is 1. Anything to the power 1 is 0. So imagine there's a 1 here and a 1 here. 1 minus 1 is 0. All right. So now,
It's much harder for you.
am I missing anything here?
Yes, you gotta put it together.
Yeah, we need to put a sign joining these. Our same sign is here. But this is a negative. Oops, I wanted a highlighter. So we need a negative sign separating the two terms together. 2k minus 1. Okay? All right. All right, Harmon. The next question, our final answer is going to have how many terms? Can you tell me? Sorry?
3.
Yeah. We have 3 terms in our numerator. Ooh, that jumped. We have 3 terms in our numerator. Our final answer is going to have 3 terms. So I'm going to just right now set up my 3 fractions. 1, 2, 3. The bottom denominator does not change. It's what we started off with. Okay. First term is the numerator in the first fraction. Second term is the numerator in the second fraction. Third term is the numerator in the third fraction. Right? And we use the signs in the numerator to separate these fractions apart. So first one, between first and second is a plus. Second and third, we put a minus sign. Okay. First fraction. Yeah, we divide the numbers together. So if I give you whole numbers, keep the answer as a fraction. If I give you decimals, you can divide it and give me the answer as a decimal. 1.4 divided by 2, that's 0.7, and Izzy said D. Do people agree or disagree with Izzy on that answer?
D3?
Oh, I heard 2 different answers. I heard a D and a D3. What do you guys think?
D.
D. We're subtracting the exponents, right?
Oh, yeah.
When we multiply, we add. Right? Okay. Middle fraction.
0.9k because 1 minus 1 is just 0, so you can put
Yeah. So 1.8 divided by 2 is 0.9. The d on the top and the d on the bottom cancel out. And you're left with a k.
and then we 0.8.
Last one,
Or just 0.8.
1.6 divided by 2 is 0.8. And what about the d?
Gone.
Gone. D on the top and the d on the bottom cancel each other out. Okay, so I have 3 terms sitting there. Is it fine?
No.
What am I missing, Hannah?
You bring down like the
plus.
The
plus
plus
and the minus.
Minus.
and the minus.
Will you lose marks for not putting it into a fraction and then doing it? Like, 'cause
How are you gonna get the answer?
you just
Yeah.
do 1.4 divided by 2 with the calculator.
That's smart.
You know what? It's easier to make mistakes if you don't separate into fractions. I know you can. Most of you guys can probably look at this and do this, but when you start dealing with a negative denominator, there's lots of chance of making a mistake. So if you just give me a final answer, I'll look at it, but I'll give you a 0 if it's wrong. Where you show me the works, I can see the logic you're going through.
Yeah.
All right.
So you won't lose marks.
That's silly, man.
All right. So Harman, how many fractions do I set up here? This one right here.
2.
Good. All right. Corey, what's the denominator here for the fractions? Huh? What's the denominator for the fractions? What denominator do you see currently for this question? What's the denominator?
So you forgot like Harmon.
Shh. Right? 5x. The same denominator continues on. 5x, 5x. Okay? All right. What's the number on top of the first fraction?
15x squared.
15x squared, same as the first term, and 20x here. And we keep the same sign. Minus sign, minus sign. Okay. What does the first fraction simplify to?
3y. Or 3x.
3x. 15 divided by 5 is 3. And dealing with the x's, x squared and an x. Subtract 2 minus 1 is 1. Okay. Okay, next one.
Wait, what?
3x.
It's before.
Just before. 20 divided by 5 is 4, and the x's cancel out, so just a 4. And we make sure to bring that negative down with us. 3x minus 4. Okay. Okay, try the next two. And I'll slowly put up the answers. All right, so see if you can do it. Yeah.
Can you write it out? Would these two equal a plus?
Yes.
Okay, so that would be plus 4c.
Yes.
And then that would go, c, and that would be negative 2.
Yes. She's got it. Yeah.
For the M N one, right?
Yeah.
Oh yeah. The M cancels the N, right?
Yeah, and we left with the N. All right. So shh, this should be fairly straightforward. I think the hardest one is the last one, where the trick is just paying attention to the signs here. So make sure on the middle one, 2 negatives, make a positive.
How would it be c squared?
You're not C.
Cause nothing cancels it out.
Nothing cancels it out. We have a c squared on the top, no c in the bottom. All right? The third term, we have a positive and negative. They combine to make a negative.
100% correct.
All right?